Welcome to the deep dive. Today, we're tackling a really persistent challenge in healthcare. It's about reducing patient harm during anesthesia.
Yeah, it's been a goal for decades, hasn't it?
It really has. And you might be shocked, honestly, at how common medication errors are. We're talking wrong drug, wrong dose.
Things you just assume shouldn't happen.
Exactly. They can happen in like 1 out of every 20 perioperative medications given. And the really frustrating thing, about 80%, 80 are seen as preventable.
80%. That's huge.
It is. But despite, tons of suggested fixes over the years, we haven't really seen widespread success in cutting down this harm. It's been quite elusive.
And that's really why our mission today isn't just about pointing fingers at individual mistakes. We're going deeper.
Okay.
We're going to dive into the hidden complexities of the whole system. We'll explore how some new tools, specifically something called SEIPS 101, can help us actually understand and maybe, finally, improve how anesthesia meds are delivered.
SEIPS 101.
Yeah, it's about really mapping it all out, pulling back the curtain.
All right, let's unpack this then. I'm interested in the CPS 101 tools. How do they actually use this systems engineering initiative for patient safety model on something as dynamic as anesthesia? What does that involve?
That's a great question. So the researchers, they didn't just watch. They use SEIPS 101 almost like a diagnostic toolkit. Think of it like mapping the DNA of a really complex clinical system.
Okay. Exposing connections and maybe friction points.
Exactly. Hidden ones often. And they really put in the work. We're talking over 100 hours of direct observation across 38 different anesthetics, plus detailed notes, interviews with the staff, doctors, nurses.
Wow, okay.
And of course, looking at all the existing literature too. A proper deep dive.
So 100 hours of observation.
Yeah.
What did all that meticulous mapping actually show? What was the big finding?
Well, the kind of shocking truth. Anesthesia medication delivery. It isn't a simple checklist, not even close.
Right.
It's more like a dynamic, sometimes unpredictable performance. The core finding really highlights its profound complexity. It's often chaotic, actually.
Chaotic.
In a way, yes. It's definitely not linear. Imagine trying to conduct an orchestra where musicians keep swapping instruments. Maybe the sheet music changes halfway through.
And the stage is moving.
And the stage is moving. That's the kind of nonlinear environment we're talking about. You often have like 6 to 8 different team members involved for just 2 patients.
6 to 8, wow.
Yeah, interacting with all sorts of different devices, multiple information sources, sometimes even in different physical rooms or parts of the OR.
Talk about a moving target. And they actually mapped this organized chaos, right, using something called an anesthesia PT scan.
That's right. PT stands for people, environment, tools, and tasks. It really lays bare how important things like good teamwork facilitators can just get undermined by simple barriers.
What kind of barriers?
Oh, things like different providers just having their own way of doing things, their preferences, or even really mundane stuff like tangled power cords getting in the way or just cramped workspaces. It's this constant dance of adjustment.
A constant dance that captures it.
And what's really fascinating is the study makes it clear. There's just no single right way to deliver these medications safely.
No single right way. That feels counterintuitive to safety thinking sometimes.
It does, doesn't it? But it means real clinical expertise isn't just about the textbook skills. It's maybe fundamentally about the clinician's ability to constantly adapt, on the fly, adapting to different teams, different tasks, new tech, changing processes, even shifting desired outcomes.
Okay, and that connects right back to what you said earlier about why some previous interventions didn't quite work or had mixed results, like barcode scanning or really strict standardization protocols.
Exactly. Those approaches, they seem logical, right? Very neat on paper, but they can sometimes inadvertently increase the workload.
Makes things harder.
Yeah, or lead people to find new shortcuts, maybe unintended ones, because the protocols are just too rigid. They don't account for that inherent need for human adaptation within the system.
So the very thing meant to help can sometimes hinder if it doesn't fit the reality.
Precisely. And if we sort of zoom out to the bigger picture, this whole analysis really pushes back against the idea that success or failure is all down to one person.
Right. It's easy to blame an individual error.
It is, but often these errors are more like a failure of the system itself. The system failing to manage or adapt to its own inherent uncertainty and complexity. It's not always just about someone having a situational awareness failure or, a cognitive bias. the system sets them up sometimes.
That shifts the focus quite a bit.
It really does. And it raises a crucial question for everyone involved in healthcare safety. How do we actually develop interventions that help clinicians understand when to adapt and how to adapt best?
Instead of just stopping adaptation.
Yes. It means moving beyond just blaming violations. When someone deviates from a strict protocol, we need to foster more open discussions, trying to understand the real trade-offs people are making constantly within the actual work system.
So the radical thought here, what's the takeaway for you listening? Maybe instead of trying to standardize every single human behavior, which might be impossible anyway, we should focus on designing systems that embrace that necessary human adaptability. Weed out the unnecessary chaos and variation, sure, but actively support the smart, on-the-fly problem-solving that keeps patients safe.
Building resilience into the system, learning from everyday work how things actually get done safely despite the challenges, not just reacting after an error.
Exactly. So for you, whether you work in healthcare or just observe complex teams anywhere, this idea of necessary variation versus unnecessary variation, it might totally reshape how you think about efficiency and safety. Something to mull over next time you encounter a complex system.